All right, next question up. But as always, we begin with the question sentence to understand the goal of the problem. So here it says, how far apart are the boats after 5 hours? All right, perfect. So we want to know again how far apart the boats are. Everyone, can we confirm right here that how far apart means distance? And on top of that, we're given the time as 5 hours. Yeah, regardless, that's the very first part of every question success. Understanding what we're going for here. The how far apart, again, that is distance. So I'll go ahead and make sure that that's very clear. I'm trying to calculate that. And the time that I'm given, again, 5 hours. So I have that there. Nice and neat. So up next, what we're going to do is we're going to understand the scenario because we have these two boats. We don't know if they're sailing with each other, towards each other, away from each other. We don't know. And how this story is presented will really affect how we're going to handle things. So pay close attention here. It says two patrol boats depart from the same dock simultaneously. Boat A travels downstream. I'm not even going to read these details. I don't care about that. So boat A travels downstream while boat B heads upstream. Okay, so I have my information here, everybody. So here's what I was able to extrapolate before the numbers. Don't worry about the numbers. Here's what I know now. This is the starting point right over here, okay? This is our starting point. And then we have one boat going upstream and another boat going downstream. Everyone, what do I do with the distance for the first boat and the second boat to get the total distance apart? What am I going to do with their individual distances for boat A and boat B? Yeah, if we take a look at it, if we visualize it, it really looks like we're going to add. And that's exactly what we'll do. That's exactly how we're going to take care of this problem. But again, pay close attention. We are going to take the distance that boat A travels and the distance that boat B travels. And then once we have them, we can add them together. Or there's going to be a much faster way we can do this. And I'll show you here at the end. So let's not waste any time. So first what I'll do is I'm just going to replace A and B since B is the one going upstream, A is the one going downstream. But never mind that, because next we're going to find the distance for each of them individually and then just add those distances together and we're done. That's it. So here we go. So for boat A, we know the time is 5 hours. We just have to know the rate. So everyone, for the rate for boat A, what is that going to be? Well, when I take a look right over here, let me highlight this here in blue. All right. So when we take a look at boat A, it travels downstream the still water speed of 23 miles an hour. Everyone, am I going to throw in 23 miles an hour for the rate, or am I doing something with that 23? Because it says the current is 4 miles per hour. So we got to take care of that. Absolutely. What do we do with that 4 miles per hour, everybody? Do we add that or subtract it from the 23? Yeah, the answer is going to be add because we are going downstream. Don't forget right here, the keywords are important. Traveling downstream, so that means we're going with the current. So it'll be 23 miles an hour plus that 4. So that's going to end up being 27 miles per hour. So there we are. We have my actual rate. That is 27 miles an hour. We can multiply that by 5, nice and easy, and we can get that going. So distance equals 27 times 5. Help me out, everybody. 7 times 5, that's going to be 35. Carry the 3. And then 2 multiplied by 5 is 10. Carry the 3 is 13. So we have ourselves 135 miles. I'm just going to write that in green, 135 miles. And now let's go ahead and find boat B. Let me just take this over here, make it a little smaller, and let's take care of boat B. For boat B, the original rate that I have, everyone, is going to be 19 miles per hour. But what do we do with the current, everyone? What do we do with the current? Yeah, we're going upstream for boat B. We're fighting the current. So that 4 miles an hour, that's going to be subtracted. Because again, it's making us slower. If we fight nature, if we're fighting the current, well, we're going to be going slower. We're going to have energy reduction. So here, 19 minus 4 is 15 miles an hour. What are we going to be multiplying the 15 miles per hour by, everyone? I know I said it, 5. So we have the 15 multiplied by 5 right there. 5 times 5 gives us 25. Carry the 2. And then the 1 times the 5 is 5. Carry the 2 is 7. So there we are. We have 75 miles right there for upstream. So everyone, we're finally back to the end. What did we say we were going to do with the distance upstream and downstream for boats A and B? Yeah, we said we would add it together. We have the distance for A, the distance for B. Add those together and we are done. 135 summed up with 75. 5 plus 5 is 10. Carry the 1. 3 plus 7 is 10. Carry the 1 is 11. And then that'll end up being 2. And there we go, everyone. The correct final answer here will be 210 miles. Booyah, nice and easy. And another way that we could have done this to get this super quick once we knew the numbers is this. Once we knew the numbers, everybody, so once we have the 15 miles per hour and the 27 miles per hour, we can add those together to get 42 miles per hour, because if we're adding the distances, we can add those rates. And guess what? 42 miles per hour times 5 would have given us 210 right away. But either way, there we go, my party people. The correct answer here is answer choice C, 210 miles per hour. All right, so in this problem that we see here on the screen, first things first is, well, we're asked, hey, how many cubic feet can the crate hold? So when I read that, although it's not explicitly said, we are being asked to calculate volume. The key word that gives it away, how many cubic feet? Right there, that phrase. Remember, my party people, when we're given or asked to find square footage, we might be talking about area or surface area. Either way, still area. When we're talking about cubic units or cubic feet, yeah, we're talking about volume. So I know that's what it is right over here. Bam, cubic feet is what gives it away. And then we're told that we have this shipping crate, which measures this in length, width, and height. That's a rectangular prism, which means my volume formula is going to be length times width times height. When we plug in our values, we have 6.5 for that length, 5 for the width, and then 4 for the height. Let me go ahead and just copy everything over properly instead of looking and writing at the same time. There we go, 4 feet for that height. So when we go ahead and move forward with the calculation, most of us go left to right and we do 6.5 times 5. But that can actually make your life a little bit easier because we can do the 5 times 4 first, and that'll give us 20. So we have 6.5 multiplied by 20. And then from there, we'll go ahead and do 20 times 6.5 right over here. So that'll be 0 times 5, 2 times 5, that'll be 10. Then we'll move over to the next line. And then we have 0 times 6. Then we have 2 times 6, which is 12. Add everything up, and we seemingly get 1,300. But what this actually is, after moving that decimal place back, is 130. And there we are. That's the correct answer here, everyone. The correct answer here is 130 cubic feet. Answer here is answer choice C.